on lambda m of weak electrolyte. And strong electrolyte. Yes, Mariam, can you turn your mic on now? Yes, Mariam. What happened to your mic, right? Telling her, I don't know what to do now. Okay. Now, I want all your concentration on the screen right now, and please write strong electrolyte. What happens on dilution to strong electrolyte? Now, strong electrolyte, you all know that strong electrolyte is something that gets dissociated almost completely, right? So please write when solution of when when solution is diluted, when solution is diluted, lambda m of the molar conductivity of strong electrolyte increases slowly. Increases slowly. Why does it increase slowly? Because it has almost been completely dissociated. And when something is almost dissociated, if you are going to dilute it, its dissociation will happen, but that dissociation will not be too large. It will be very small dissociation, very small increase in dissociation will happen. And that small increase in dissociation is going to correspond to the small increase in the lambda m. So lambda m increases slowly because strong electrolyte is almost completely dissociated. Is almost completely dissociated. Due to which graph of lambda m versus root of concentration is linear for strong electrolyte. For strong electrolyte, the graph is linear, meaning it will look something like this. See, पहले यहाँ पे हम लिख देते हैं क्या क्या चीज है. यहाँ पे आपके पास लैम्डा m, यहाँ पे आपके पास रूट c. Right? Now you are going to slowly start the dilution. That means your concentration is high right now. When concentration is high, molar conductivity is low, and then your graph will start to. And what you're doing, you're diluting it, so concentration decrease करेगा. As the concentration is decreasing, approaching zero, lambda m is going to increase because on dilution, what happens? Molar conductivity increases. So graph is going to be like this. On decrease, generally graph आप कहाँ से जान जाते हैं? Go from left to right, but in this case you have to think in the terms of right to left. You're diluting things. You're adding water. Concentration is getting smaller and smaller. Concentration is decreasing. Molar conductivity is increasing. So the graph will look something like this. Okay. And what we can do, we can even extrapolate it like this. We can extrapolate it. It does not reach this. I mean, it does not reach zero. But let's suppose आपके पास एक don't draw it right now. So the graph you get is still here. After that, what do we do? After that, we extrapolate it. I hope you all know what is the meaning of extrapolation. We extrapolate it, and this point, you can see, this is the point where you are having the maximum molar conductivity. At concentration zero, that means you have done infinite dilution. You have diluted so much that concentration has become so small that it is approaching zero. And this concentration, it is this molar conductivity, it is known as lambda m naught. the molar conductivity of infinite dilution. Right. So from this graph itself, we can see, right, lambda naught m of strong electron can be determined using this plot. This plot follows Debye-Huckel equation. The Debye-Huckel equation is molar conductivity at a particular concentration is equal to the limiting molar conductivity at infinite dilution minus the constant B root under B. So y is equal to mx plus c type of graph आपको बन रहा है y है, this is the c, that is the intercept, this b is m and this root x is x. ठीक है, this b is the m slope and this b it depends on charge of ion and temperature. Like what type of charge ion and so this is very important in the question. You can see this particular graph and you have to identify whether it is strong electrolyte, weak electrolyte, and so on. Right? After this, we are going to look at weak electrolyte. Raise your hand once you're done. Just waiting for Amna. I hope all of you understood this, that if because strong electron is always very slow increase in the lambda n. But in weak electrolytes are partially dissociated. When solution containing weak electrolyte is diluted, then lambda m increases sharply because weak electrolyte is only partially dissociated. It's only partially dissociated, and as the dilution increases, the dissociation of electrolyte also increases. Then the also increases. Hence, the graph of hence the graph between lambda m versus root c is not linear. Hence, the graph between lambda m and root c is not linear. So, how does the graph look? Don't draw the graph now. Let me draw it, and then you will be able to draw it easily. So, it increases like this. Okay. So, again, here also we are going to have lambda molar conductivity. Here going to have root c. So, as the concentration is decreasing in this way, the lambda m is increasing very sharply. And it is increasing very sharply. Now, you can see from this particular graph, you will never be able to reach the y-axis because the y-axis is going to reach, sorry, the plot is going to reach the y-axis at infinity. It's going to keep on going up, right? Above, 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 above. So you can say that it is evident that lambda naught m of weak electrolyte cannot be determined from this graph, right? And for this, we have the Quadros law of independent dilution, and that is for what? That is for the determination of lambda naught m, the molar conductivity at infinite dilution for weak electrolyte. Please write this down. We are going to see a question, and then we are going to move forward. So these graphs are and everything are important. Okay. Raise your hand once you're done. Waiting for Amna and Taha. You understand? See it. In the plot of molar conductivity versus square root of concentration, the curves obtained from two electrolytes A and B. So these are the two plots that we have got. Okay. अब यहाँ पे they are asking predict the nature of electrolytes of A and B. So you can very easily say A is what? It is strong electrolyte, and B is what? B is weak electrolyte. That's it. एक marks मिल गया आपको. What happens on extrapolation of lambda m to the concentration? What happens to the extrapolation of lambda m to concentration approaching zero for electrolyte A and B. So for A, you can say that if you are going to extrapolate it, then you are going to get what? For A, what's going to happen? We will get the value of lambda naught m, the molar conductivity at infinite डायरेक्शन, उसकी हमको क्या मिल जाएगी? उसकी वैल्यू मिल जाएगी, राइट? अच्छा, वही चीज अगर हम किसके लिए करें? वही चीज अगर हम करें for the weak electrolyte, then we know that for weak electrolyte, the lambda m is going to increase steeply on dilution. And extrapolation to the zero concentration, it is not possible, right? It is not possible for weak electrolyte. For weak, the lambda m will keep on increasing, as concentration reaches zero, till infinity, you can say. Therefore, मतलब इसके possible नहीं है. Therefore, you can write lambda naught m of weak electrolyte cannot be determined. एक तो ये हो गया सवाल, ठीक है. आई होप ऑल ऑफ यू अंडरस्टूड दिस पार्ट, है ना. नो नीड टू राइट इट वेरी टू मच, ठीक है. इसको बस समझ लीजिए एक बार, बिकॉज द क्वेश्चन इज वेरी लॉन्ग, and if you want to take a screenshot, you can take a screenshot and then you can write it later on. Understood all of you? Amna, Sufyan, Yasan, official me. Amna, Sufyan, Taha.
Yes, sir.
ठीक है. So basically the things are going to be like almost on the notes only, है ना. बिल्कुल notes नहीं होगा. अब जैसे एक और सवाल है, this like requires a bit of logical thinking. No, not this one. This was asked in 2023. On diluting A and B, diluting two electrolytes A and B, then lambda m of A increased 25 times. A में increase कितना हुआ? 25 times. While that of B increased by 1.5 times. B में जो increase था, that was 1.5 times. Which of the two electrolyte is strong? Justify your answer graphically. Right. So we know that. Like, where is the large increase? Tell me. Where are we getting a large increase? Where are we getting a large increase in A or B?
A.
In A, right? And a large increase on dilution is a property of what? Weak electrolyte. When solution containing weak electrolyte is diluted, then lambda m increases sharply. Then lambda m increases sharply. So what does that mean? It means that a high jump in the lambda m, it suggests a weak electrolyte. So for A, we can say that it is increasing like this. And what is happening with B? It is increasing, like very small increase. It will be like this. Make it from another graph. Then you can say that this is the B electrolyte and this white one is the A electrolyte, lambda m, and then you will write 2. Okay, you can make, take a screenshot. So A is going to be what? Weak electrolyte. B is going to be strong electrolyte. And the reason यहाँ पे हमारे पास है notes नहीं मौजूद है ना, you will write this part. ठीक है, when weak electrolyte is diluted, lambda increases sharply because weak electrolyte is only partially dissociated, and as the dilution increases, dissociation of electrolyte also increases. यहाँ पे because कर लीजिएगा, because strong electrolyte is almost completely dissociated, due to which the graph of lambda m is linear for strong electrolyte. Done till here, yes or no, please tell me. I hope you have taken a screenshot.
So,
all of you done? I'll wait 5 more seconds. 5, 4, 3, 2, 1, and 0. Now, how can we determine the limiting molar conductivity of weak electrolyte? So for that, we have the Kohlrausch law of independent migration. Okay, please write. Walrus law of independent migration. The law is quite simple. The lambda naught m of an electrolyte is equal to the sum of molar conductance of its contributing ions at infinite dilation. The lambda naught m of an electrolyte is equal to the sum of molar conductance of its contributing ions at infinite dilation. क्या मतलब इसका? This is how we show it. Lambda naught m, it is equal to the lambda naught of the cations plus the lambda naught of anion. For example, if I want to calculate the molar conductivity of NaCl, then this will be equal to the limiting molar conductivity of NaCl will be equal to limiting molar conductivity of Na plus the limiting molar conductivity of Cl negative. Similarly, if I want to determine the limiting molar conductivity of MgCl2, then this will be equal to the limiting molar conductivity of Mg plus the limiting molar conductivity of Cl negative. But here we are having two chlorines, so I will multiply 2 here. Because we are going to get two chlorines, na? So 2. Similarly, I hope अब आप लोग को समझ में आ रहा होगा. You're able to understand yes or no? Please tell me. आमना, सुफियान, ताहा, मरियम, बतूल अभी आई है. मरियम देखिए जरा क्या हो रहा है. Yes. So tell me guys, lambda naught of KCl, it is equal to, can you please help me here, lambda naught of, tell me, it will be equal to what, lambda naught, बोलिए, जल्दी बोलिएगा यार, इतना टाइम मत लगाओ ना यार, आप बोलने में इतना क्यों लेट करते हैं यार, दिमाग बोलो बोलो जल्दी बोलो यार, lambda naught of KCl will be equal to A plus and lambda naught of
Cl minus.
Cl minus, ठीक है, उसी तरह से चलिए, I am writing a few, I hope you will be able to understand them. Okay. Why I'm writing this? Because this should be in your notebook so that whenever you see a particular electrolyte, you're able to easily like check whether you are doing it correctly, whether you are dissociating them correctly or incorrectly. Next is lambda naught of AlCl3 will be equal to lambda naught of aluminium P positive plus P lambda naught of chlorine negative, and then we are having lambda naught of, if you have NH4OH, is equal to lambda naught of NH4 positive plus lambda naught of OH negative. Then lambda naught of CH3 COOH equal to lambda naught of CH3 COO negative plus lambda naught of H positive. Lambda naught of AgCl is equal to lambda naught of Ag positive plus the lambda naught of Cl negative. By the way, आपको लग रहा है ये lambda इधर lambda अलग क्यों जा रहा है? This is the uppercase lambda. जैसे A होता है ना, this is A and this is A. So both of this is also A, this is also A. This is also lambda, this is also lambda. This is the uppercase lambda. Capital lambda ये क्या है? Small lambda. Uppercase and this is lowercase lambda. So uppercase we generally use for the electrolyte, lowercase we generally use for ions. Generally speaking, ऐसा कोई rule नहीं है. What chapter are we going to start? Because the team is asking me what chapter I am going to start in this particular batch. क्या करें start?
सर वो आप एक्स्ट्रा क्लास कब लेंगे?
अरे डीएनएफ ब्लॉक का लास्ट, डीएनएफ ब्लॉक का नाम ना,
जी
आप 2 क्लास आई थी, यू अटेंडेड द 2 क्लासेस।
मैं मेरी मेरी लास्ट क्लास मिस हो गई थी।
लास्ट संडे को तो क्लास नहीं ले पाए थे हम, आई मीन टीम में शायद मैसेज भेजना भूल गए थे
उस
वो, तो हमने बोला
लास्ट
कि
वाली
दो,
मेरी मिस हुई
आप
थी।
आपने कितनी क्लासेस की हैं?
मैंने अभी से फेक करी है।
अच्छा, एक किया है। 2 क्लासेस हुई हैं, 2 क्लासेस और समझ लीजिए
जी
बाकी हैं। एक क्लास तो होगी संडे को।
संडे को।
हम्म, वही सेम
ठीक है।
टाइम। ठीक है, तो आपने रिकॉर्डिंग देखा वो,
ठीक है।
जो जो बैच आप, जो क्लास आपकी छोटी थी उसकी आपने रिकॉर्डिंग देखी?
जी रिकॉर्डिंग देख ली है।
समझ में आया आपको?
जी
उसको लेकिन पढ़ते रहिएगा, ठीक है ना, अदरवाइज वो भूल सकते हैं फिर आप लोग। ओके,
ओके।
व्हाट शुड वी स्टार्ट नेक्स्ट? बता दो भाई, हम यहाँ अपडेट कर दें फिर। बोलो, ये कोई कुछ नहीं बताएगा क्या? हाँ बोले सर, आप ही बता दो, हम तो जो बता रहे हो वो तो आप करना नहीं चाह रहे स्टार्ट। आप ही बता दीजिए जरा, क्या स्टार्ट करना चाहते हैं? नहीं, ऐसी कोई बात नहीं है। इफ ऑल ऑफ यू अग्री विद ऑर्गेनिक केमिस्ट्री, आई कैन स्टार्ट ऑर्गेनिक केमिस्ट्री। आमना बताएं, शुड वी स्टार्ट ऑर्गेनिक केमिस्ट्री? चलेगा आपको?
जी ठीक है।
चलेगा।
यस।
साहा, व्हाट डू यू से, शुड वी स्टार्ट?
Yes, sir.
करते हैं स्टार्ट, है ना? करते हैं ऑर्गेनिक केमिस्ट्री, स्टार्ट करते हैं, एंड लेट्स गेट डन विद ऑर्गेनिक केमिस्ट्री। आई होप यू गाइस आर डन राइटिंग, यस और नो?
यस सर।
Mariam is trying to join, and why you are getting disconnected, Mariam Batul? So we can say that lambda naught m, it is equal to number of cation into the molar conductivity of each cation plus the number of anion multiplied by the molar conductivity of each anion, है ना? जैसे फॉर एग्जांपल जब आपके पास एयर स्केल थी था, तो यू आर मल्टीप्लाइंग p, व्हाट डज इट दिस p शोइंग? द नंबर ऑफ आयंस, है ना, द नंबर ऑफ एनायंस वी आर having. ओके मरियम बतूल, आप रिकॉर्डिंग लिखना आपको देखनी ही पड़ेगी मरियम, राइट? व्हाट इज n पॉजिटिव हियर? नंबर ऑफ cation after dissociation. N negative, number of anion after dissociation. चलिए, इस लिखिएगा एप्लीकेशन, दिस इज इंपॉर्टेंट, सवाल यहीं से आता है। एक सवाल तो लाइक यू कैन हैव वेरी सिंपल क्वेश्चन लाइक state the Colbert law of independent migration. Now application part, you'll get questions from here. चलिए, the most important application from which we started the Colbert law, it is the determination of lambda naught m for weak electrolyte to determine limiting molar conductance of weak electrolytes. Okay, so we are going to understand this by a particular question. So I want all of you guys to stop writing now and please focus and try to understand. For example, I have some strong electrolytes. For example, the lambda naught of CH3COONA. This is given as X Siemens centimeter square mole inverse. Lambda naught of NaCl. This is given as Y Siemens centimeter square mole inverse. Lambda naught of HCl, it is given as Z Siemens centimeter square mole inverse. They're asking find lambda naught M of CH3COO. Okay, I'm giving you a long method right now. Like I'm telling you how this complete thing works right now, how the mind processes everything to get the answer. But you don't have to do this in a long way. We are going to slowly speed up the process. ठीक है. सबसे पहले आपको क्या करना है? You have to write the dissociation of all the different electrolytes. For example, I have been given the three data. I can write that CH3 COONA is going to get dissociated into CH3 COO negative plus Na positive. Then NaCl is going to get dissociated as Na positive and Cl negative. HCl is going to get dissociated as H positive and Cl negative. Fine. So these are the given data. For this, you have X, this is Y, and this is Z. Now you have a target. What is the target? That CH3COOH is going to get dissociated as CH3COO negative plus H positive. Fine. And ध्यान से यहाँ पे सुनिएगा ये बात that these things should happen in your mind after this particular question. I'm showing each and everything, but expected क्या है आपसे that this occurs in your mind, that you are able to, when you are going to look at an electrolyte, you are able to identify the dissociated ions. Now using these dissociated ions, you have to form this particular reaction. ठीक है, ध्यान से देखिए जरा कैसे करना है. Look at the product. ठीक है, this is the target. You need CH3CO negative, you know ना कि lambda naught of CH3COOH will be equal to lambda naught of CH3COO negative plus the lambda naught of H positive. Now please turn your mic on and tell me, in the given information 1, 2, 3, X, Y, Z, where do you find CH3COO negative? In which equation do you see CH3COO negative, X, Y, or Z?
X.
That means you need X. Now in X we have CH3COO negative, and there is one thing extra. What is extra? Na. So I have to do what? I only want the CH3CO negative, so I don't want the Na. Plus. Where do you find H plus in X, Y, or Z? Where do you find H plus in X, Y, or Z? What?
Y.
Y में H plus कहाँ है यार? आमना.
Z sorry.
Z में ना? ठीक है ना? Z ठीक है. Z, and what is extra in the Z? What is extra? बोलो, what is
Cl.
extra? Cl. So minus lambda naught of Cl negative. Now you will write it like this: X plus Z. ठीक है? I have taken minus in common, and I have got lambda naught Na positive plus lambda naught Cl negative, right? Because we have both in negative, so I've taken the negative common, minus Na plus and Cl negative. So this becomes what? X plus Z, and this is Y. Can you see that? Yes or no? Please tell me.
Yes, sir.
So this is how it happens, but I hope you can see that you can do things fastly also. Now, like how the mind should work, like what is the logic behind all of these things I have shown, but I hope you can guess, na guys, Amna, Sufyan, Taha, that how to do this fastly, quickly. because this will be coming in 1 mark only. So you don't have to do show each and all of these things. You just need to do x plus y, x plus z minus y, and those x, z, and y is going to be some numbers. हो जाएगा? क्या ख्याल है, बताएं. गाइस टेल मी. बोलो भाई. सत्यान, ताहा, आमना, will you be able to do it quickly?
Yes, sir.
Whatever you need should be whatever you need should be positive. Whatever you don't need should be in negative. Raise your hand if you're done. सवाल नहीं लिखा तो थोड़ा जल्दी कीजिएगा. And for Amna, Mariam, and Sufyan. This is one of the easiest topic और यहाँ से सवाल आते हैं. ठीक है ना. 2-3 मार्क्स आ जाता है. आसान सवाल भी रहता है लेकिन 2-3 मार्क्स आ जाता है. चलिए, I'm giving you a question, okay? हो जाएगा ना. आइडेंटिफाई की देखते किसका सबसे पहले आंसर आता है. ओके, ताहा has got it. भाई इतना लंबा नहीं करना, जल्दी करना है ना आप लोग को. चलिए, तो माइक ऑन करके कीजिएगा. जल्दी जल्दी हम सिखाते हैं जल्दी कैसे करना है. चलिए चलिए, माइक ऑन करो. माइक ऑन बोलो. माइक ऑन तो करो. टर्न योर माइक ऑन गाइस. आमना, सुफियान, मरियम. मरियम मतलब तो नहीं. ताहा नहीं किया है सर. ताहा आपको तो आंसर आ गया, उसको हम देखते हैं. लेकिन मरियम, ठीक है. मरियम, वेयर विल यू गेट NH4? फ्रॉम वेयर विल यू गेट NH4? फ्रॉम वेयर विल यू गेट NH4 मरियम? X, Y और Z NH4. Oh my God. What, Amna?
X,
X. Where will you get OH from? Where will you get OH?
Y,
Y. What is extra in X? What is extra in
CH,
X?
minus.
CL minus what is extra in Y?
Na.
Okay, na? X plus Y minus Z. Yes, correct मरियम. ठीक है, that's it. एक मार्क्स आएगा ना, इससे ज्यादा कुछ नहीं, नंबर्स आएंगे एक्स वाई जेड. You just need to do some addition subtraction. चलिए अगला सवाल हम करते हैं. ठीक है, यहाँ पे देखिए ये this type of question, the second type of question that I'm asking, that has never been asked. इसी तरह के हमेशा से सवाल रहते हैं, ठीक है, इससे भी आसानी रहता है. तो इसी तरह के हमेशा सवाल रहते हैं, राइट. एक और आपको बता रहे, ये थोड़ा सा हार्ड है, बस थोड़ा सा. तो बेट नहीं, कंसेप्ट वही सेम. देखिए NH4Cl lambda naught of NH4Cl, it is equal to X by Siemens centimeter square per mole. Lambda naught of BaOH whole twice, it is equal to Y, and lambda naught of BaCl2, it is equal to Z. Need to calculate the lambda naught of, this is lambda naught, need to calculate lambda naught of NH4OH. In solution, obviously, lambda naught of NH4OH, I will get the NH4 from X, I will get the OH from BaOH whole twice, but since here we are having what? Barium hydroxide, na? In which we are having two hydroxide. I need only one hydroxide. So what I will do, I will take Y, but I will half it. Because I need one, इसके पास दो है, तो दो को दो से डिवाइड कर दीजिए, we will get one barium hydroxide. Now what are the things extra? Extra वाले को माइनस में रख के प्लस कर देते हैं ना. The extra part in the NH4OH was Cl. I don't need Cl. And what is extra in? ध्यान दीजिएगा. What is extra in BaOH whole twice? It is barium 2 positive, but only half. Because हमने तो half ही लिया था ना. OH was twice. That we needed one. That is why we divided by 2. Right? But इसकी वजह से क्या होगा? Ba भी half आया होगा. We have got half Ba. Right? Now you can see that X plus Y by 2 minus 2Cl negative plus Ba positive. Ba2 positive divided by 2. And what you can see from here is X plus Y by 2 minus Ba and 2 chlorine. This is going to be what? Z divided by 2. इसको समझ लीजिए जरा अच्छे से. डन गाइस, समझ में आया ना सबको? आमना, मरियम, सुफियान, ताहा.
Yes, sir.
ठीक है. This type of question has never been asked in the board examinations. I hope you can see the MCQ type of questions which can be framed from this particular topic. This was the main application. The other applications are just the extrapolation of the same application. Amna, Sufyan done, Taha done. दिख लिया होगा ना आप लोगों ने तो.
Yes, sir.
चलिए ठीक. नेक्स्ट एप्लीकेशन is second. To determine degree of dissociation of weak electrolyte. You know that degree of dissociation it is equal to alpha, and alpha क्या बताता है आपको? For example, अगर alpha आपके पास 0.1 है, that means 1 out of 10 is being dissociated. यही मतलब हुआ ना? If alpha is this here, if alpha is 0.1, what does it mean? It means that 1 out of 10 species is being dissociated. Make sense? Yes or no? Please tell me. Amna, Sufyan, and Taha. बोलो जल्दी बताओ. यही मतलब है ना? Right? Now please understand it very carefully. Right? This is dissociating at a particular concentration. But if we are going to dilute the weak electrolyte infinitely, then all the ions, all the electrolytes, each and everything is going to get dissociated. This is going to be at what? At infinite dilute. And from this concept, we can say that alpha will be equal to the lambda, that is molar conductivity at some concentration C divided by the molar conductivity at infinite dilution. अब क्या करते हैं वो देखिए, हम बताते हैं आप. What they will do now, you have two things. ध्यान से देखिए, how the questions are being framed, वो हम आपको बता देते हैं. This is your alpha. Please see, don't write now. Molar conductivity at a particular concentration C. This वो क्या करेंगे ना, ये आपको ये नहीं देंगे. They will not give you the numerator. What they will give you, they will give you the conductivity and concentration. And we know that lambda m it is equal to kappa into 1000 upon molarity. We'll use this particular formula. They will give you kappa. They will give you molarity. है ना? You can calculate the molar conductance at this particular molarity ना, उसी को यहाँ numerator में डालना है. And they will not give you the lambda naught m, rather they will give you the limiting molar conductivity of cation and anion. उसको add करना होगा बस आप. Molar conductance of cation and molar conductance of anion ये दे देंगे और उनको ऐड करना. जरूरी नहीं सारे सवाल में ऐसा करें. कई दफा ये होता है कि दे गिव यू द लिमिटिंग मोलर कंडक्टेंस, इसको दे देते हैं, ये आपको निकालना पड़ता है. ठीक है. Sometimes what happens, they will give you this one and that you will have to add. Sometimes they will never give you either the numerator nor the denominator. Both the things will be calculated. ठीक है. So this lambda naught, lambda mc can be calculated from this particular equation. Lambda naught m can be derived if we have the molar conductance of the cation and the anion. Please write this down. थर्ड लिखिएगा. To determine dissociation constant of weak electrolyte. Then everyone is please tell me.
Yes.
Dissociation constant of weak electrolyte, it is given as, this is from equilibrium, K it is equal to C into alpha square minus 1 minus alpha. You know that alpha it is equal to, we have just seen lambda mc upon lambda naught m, fine. So the dissociation constant capital K will be equal to the concentration C, and alpha square will be what? Lambda m at a particular concentration divided by lambda naught m square divided by 1 minus lambda m at a particular concentration divided by lambda naught m. इतना नहीं करना पड़ेगा, अल्फा पहले कैलकुलेट कर लीजिएगा, उसको यहाँ प्लग इन कर दीजिएगा, दैट्स इट, ज्यादा लोड नहीं है। आपको हम सारे टाइप के सवाल ना एक बार दिखा देते हैं, ठीक है ना, डोंट हैव टू वरी अबाउट इट, इसको लिख लीजिए बस। In these cases you have to be a bit courageous and do the calculation. सवाल इंतहाई आसान रहेंगे, इट इज कंप्लीटली स्टेटिक फॉर्मूला बेस्ड क्वेश्चंस, बट यू जस्ट नीड टू बी अ बिट करेजियस, हिम्मत दिखा के थोड़ा बस क्या कीजिए, कैलकुलेशन करने की हिम्मत रखिए। Raise your hand if you're done writing, then I will show you the questions. Just waiting for Taha. So I've taken 3 questions, ठीक है, ध्यान से देखिए, आसानी से हो जाएंगे सारे सवाल, you have to worry too much. See the first question. Calculate the degree of dissociation of CH3COH if lambda m and lambda naught m of CH3COH are 48 and, तो देखिए, I mean this is like अल्फा निकालना है आपको, दिस इज इक्वल टू लैम्डा एम अपॉन लैम्डा नॉट एम, राइट, लैम्डा एम एट पर्टिकुलर कंसंट्रेशन व्हिच इज इक्वल टू हाउ मच, लैम्डा एम आपको कितना दिया हुआ है 48 एंड लैम्डा नॉट एम कितना दिया हुआ है 400, दैट्स इट, आ गया आपका आंसर, खत्म, सवाल खत्म, ये वाला कुछ नहीं करना था इसमें। नाउ लुक एट द नेक्स्ट क्वेश्चन, द कंडक्टिविटी, प्लीज लुक एट द नेक्स्ट क्वेश्चन, ठीक है ना, डोंट वरी टू मच अबाउट द कैलकुलेशंस, लुक एट द नेक्स्ट क्वेश्चन। द कंडक्टिविटी ऑफ 0.01001 मोलर एसिटिक एसिड इज कितना, दे हैव गिवन यू द कापा, आई होप आप समझ रहे हैं कि सवाल कहाँ जा रहा है। कापा दिया हुआ है आपको कितना, 7.8 इंटू 10 टू द पावर -5, एंड मोलारिटी कितनी दी हुई है, दैट इज 0.001 मोलर। कैलकुलेट द डिग्री ऑफ डिसोसिएशन, दैट इज अल्फा, कैलकुलेट द डिग्री ऑफ डिसोसिएशन फॉर, if lambda naught m of acetic acid is 390, lambda naught m is also given, that is 390. So from these two values, we can calculate the lambda m at this concentration, that will be equal to kappa, that is 7.8 into 10 to the power -5 multiplied by 1000, that is 10 to the power 3, divided by 0.001 will be equal to 1 upon 10 to the power 3, right, 1 to 3. So 10 to the power 3 will go above, it will become 7.8 into 10 to the power -5 into 10 to the power 6, which will be equal to 78, and then what you can do, alpha will be equal to lambda m upon lambda naught m, which will be equal to 78 upon 390, and this will be equal to how much, 0.5, no? 39, अगर 10 कर दें हम यहाँ पे, 39 2 0, right, so it will be 2 upon 10. Does that make sense? Yes or no, please tell me, guys. Guru,
Yes, sir.
right, this will be equal to 0. What? 0.2. देख रहे कितना आसान सवाल है, this must be of at least 2 marks or 3 marks. Like if you try to relate it with the Nernst equation, relate नहीं करना, so sorry, not relate it, rather if you want to, what I can say is, if you want to compare it with Nernst equation, this is very easy. Nernst equation is going to be of 3 marks, and this question is going to be of 2 marks. Now this 55 question is I think of 3 marks, इसको भी देख लेते हैं, 55 या 55 one is of 3 marks, ठीक है। देखिए कितनी जल्दी ले, Nernst equation आप समझ रहे हैं, you need to know the cell reaction, you need to know the number of electrons, you need to know the log, so many things, and you need to have good calculations also. Here you see how easy these calculations are. Now, the last one says the conductivity of itna molar methanoic acid is itna. That means it is saying that molarity it is equal to 2 into 10 to the power minus 3, and the conductivity, that is kappa, it is equal to 8 into 10 to the power minus 5, and the degree of dissociation of lambda naught m, it is given. Lambda naught is given as 404. Now, both of these questions are not any different, right? But this can be asked for 2 marks as well as of what 3 marks. This is of 3 marks. But same सवाल है. From these two, what do we need to calculate? We need to calculate the molar conductivity and degree. दो चीज निकालने के लिए कहा है, लेकिन in this case, I think they have not asked to calculate the molar conductivity. Calculate degree of dissociation only. But in order to calculate the degree of dissociation, we have to calculate the molar conductivity also. है ना? Yes. So we need to calculate the molar conductivity, which will be equal to lambda m, which is equal to kappa, which is 8 into 10 to the power minus 5 divided by 2 into 10 to the power 3, and 2 into 10 to the power minus 3 will go above, it will become plus 3, and this will be equal to how much? 4 into 10, that will be equal to 40, and alpha will be equal to what? Lambda m of a particular concentration divided by lambda naught m, this will be equal to 40 upon 404. So this will be approximately equal to 1 upon 100, 1 upon 10. है ना? If I take this as 0, 1 upon 10 हो जाएगा ना? Approximately 1 upon 10, and which will be equal to 0.1 alpha. 404 को आप 400 ले सकते हैं ना? You can